All right, part 2 here. 2 more examples, then I'm done. For a specific year, the average score on the SAT math test was 515. The variable is normally distributed, and the population standard deviation is 100. The same superintendent in the previous example wishes to see if her students scored significantly below the national average on the test. She randomly selected 36 students as shown at a 0.10. Is there enough evidence to support the claim? Okay, so let's go through these steps again. You'll get better at this, I promise. By the way, I've already pre-put this into my calculator, just so you know, just letting it already be in there. So step number 1, you write your HO and your HA. That's really the least you should do right now. What is this whole question about? Well, she's looking to see if her kids scored significantly below the national average. She's afraid, oh my gosh, my kids are dumb. I hope she doesn't think that. Okay, so she thinks that her mean, her average of her kids right here, these 36, is below the national average, which was what? 515. Okay. What's HO going to be? Well, no, it's equal to 515. It's probably about the average. Okay, so this is our claim. Write that step number 1. Step number 2, state your significance level. It's a lot of restating, so don't freak out if you're like, this seems like a lot. It's really just restating stuff in here. What's the significance level? Well, she chose 10%. Alpha equals 0.10. Okay? Now also state the critical value. How do you get that? From your calculator, but we got to know if we're doing a right or a left-tailed or a two-tailed. So let me just draw this out real quick. 10%, do I want it on the right, the left, or both? Well, if my claim is that it's less than, that would be on the left. I want this to be 0.10. So that's an easy input. Second inverse norm. Oh, there's a glare right here. Inverse norm. This one is easy. Just put 0.10 because it's on the left. And I get negative 1.28. That's my critical value. Okay. Now that we've calculated that, now we actually have to compute our test statistic for our example here. Remember, think of yourself as the researcher doing this. So Z is equal to X bar minus mu over standard deviation divided by square root of n. So let's read through this and see what it is. Let's see. The variable is normally distributed population. Standard deviation is 100. So we know this is going to be 100 right here. We know she randomly selected 36 people. So we know it's going to be square root 36 here. The national average is 515. Oh man, how do I get mean? Oh, you silly kids. Calculator's got it. Remember, I already put it in. So we can go to stat, or actually, what would it be? Stat calc 1 bars, right? List 1, that's where I put it in. And let's see what it's 509.03. Okay. And I'll input this into my calculator here on the side, and I get negative 0.36. Negative 0.36. Okay. Now that you've calculated that test statistic, we've got to find this p-value. How do you find the p-value? Well, you go to the z-test. Z-test. So stat, tests, z-test. Now, you can input the stats since we have most of them, or you can let the calculator use what you already inputted into L1. So I'm going to let it use the data from L1. I know there's a glare there, but I'll move it over. So let me change some things up here, though. Mu, what is the population I'm talking about? It's not 46. That was the previous problem. It's 515. Standard deviation was 100. I'm going to use my L1. Do I choose not equal to, less than, or greater than? Well, I choose whatever my HA is. My HA is less. So I'm going to choose less. Calculate. Look at that. Look at how my Z is the same thing. Negative 0.36. That's what I got. Negative 0.36. What's my P? 0.36. 0.36. Okay, now compare this P to the significance. Is the P lower than 0.10? You reject it. If the P is low, reject that HO. Is the P greater? Is the P equal to? This is 0.36 is greater than 0.10. So what does that mean? That means there's no rejection. If the P was low, you reject. So step number 4, you say, fail to reject. Those are the phrases we use. Don't say, I don't reject. Say, I fail to reject the HO. And now state what that means. Here's what you would say. Step number 5. If you fail to reject, then there is not enough evidence. There is not enough evidence to support my claim as a researcher that the students score below 515. Okay? Same thing over and over and over and over again. You got to just do enough of these. I promise you. They slow in the beginning, but they'll get faster. All right, let's do one more here. Let's moviegoer. This is actually a problem from your homework tonight. This is actually number 4. The average moviegoer sees 8.5 movies a year. A moviegoer is defined as a person who sees at least one movie in the theater in a 12-month period. A random sample of 40 moviegoers from a large university revealed that the average number of movies seen per person was 9.6. The population standard deviation is 3.2. At least at a 5% level of significance, can it be concluded that this represents a difference from the national average? All right, so let's one more time do this one step by step. Follow along. You're going to get this. You always do. You always get this. Number 1, what's my HO? What's my HA? What am I thinking? Let's average moviegoer sees 8.5 movies a year. So mu equals 8.5. What's my claim? Oh, let's see. Can it be concluded that this represents a difference from the national average? Not lower, not greater, a difference. Ooh. So it does not equal to. Step number 1. Step number 2, I want you to write your significance level. Alpha is 0.05. Critical value. Okay, so this is a two-tailed test. That means I want this side and this side, since it's a not equal to, I want them both together to be 0.05. Together. 0.05. So what do I do to Mr. 0.05? Yeah, that's right. I divide him by 2. 0.05 divided by 2 is 0.025. So in my calculator, I do inverse norm. Inverse norm, 0.025. And I get negative 1.96. And what's this guy? Positive 1.96. So I actually have 2 critical values here. Negative 1.96. Oops. And you can even write plus or minus. Negative 1.96. All right. Now, significance level, critical value. Step number 3, what do we do now? Oh, we have to compute our Z statistic. So Z equals x bar minus mu over sigma over square root n. So let's go through and read what we've got here. The average moviegoer sees 8.5. So that is the average. That is my 8.5 for mu. Do I need to write 12 anywhere? No, that's just extra information. A random sample of 40. That is my square root 40. Large university related found the average number of movies seen per person was 9.6. Oh, we got in our sample 9.6 out of those 40. And the population standard deviation is 3.2. Okay, put that in your calculator. You get about 2.17. And whoops, before I get to number 4, we got to find this p-value. How do we find that p-value? P-value. Calculator. That's right. Stat, test, z-test. Go back to stats. Input all your information. The population, it's not 515, it's 8.5. The standard deviation is 3.2. My sample, though, that I got was 9.6. And how many people did I do it from? 40 people. Which test do I choose since it's a two-tailed? Not equal to. Calculate. Look at that, Z, 2.17. What's that P? 0.029 or 0.03? 0297. Is this p-value lower than the significance? Is 0.02, really just have to go 0.03, less than 0.05? Oh, yes. Cool. So the P low, step number 4, the HO. Woohoo! And then here's what you say on number 5. If you're rejecting the HO, then you're claiming this to have enough evidence. There is enough evidence to support the claim that there is a difference in the moviegoers, et cetera, et cetera. All right. Sorry for 2 long ones, guys, but this is really, really, really important stuff. And if you do this enough, you will get it. All right? Try your homework. Bye.